Welcome to our webinar tonight, Radon in Air and Water, an overview presented by Scott Montefiore. I'm going to hand it right over to Scott and he will start. If you have any questions, just type them in, or tonight, just feel free to turn your camera on and your mic on and just ask any questions when you feel appropriate. And we'll get started right now. Take it, Scott.
So first of all, I'd like to welcome everybody. Just to tell you a little bit about myself. My name is Scott Montefiore. I'm a licensed home inspector. I have been since 2003. I'm a certified radon mitigator and tester in the state of Connecticut. National Radon Safety Board certified in mitigation and testing. And I've been doing that since 2006. I'm also here tonight with our Director of Operations, Stan Bajerski, and our IT Director and Secretary, Jim.
Yep.
So tonight, guys, I'm going to give you a basic overview. Most home inspectors, and I know in other states it may be different, but I know in Connecticut there's no standards for inspecting radon systems. So, I get guys all the time that call me and say, hey, Scott, take a look at this, take a look at that. Why isn't this working? So tonight, hopefully, when this presentation is over, we're going to give you a basic overview, what to look for. And again, if you guys have any questions about radon or any questions in general, you're welcome to shoot me an email, text me, call me, and hopefully I can answer any questions that you have. The other thing, too, for our members that are here in the live webinar, and also when this is recorded and you're looking at it in the future, if you have any presenters that you want to see or somebody that you know in your state that you would like to do a presentation for Cornerstone, just let us know, let me know, and we can hopefully get them up and do a presentation. If there's any presentation that you want to see in the next year or two, let me know, and I will do my best to get somebody to do the presentation for Cornerstone. So let's talk a little bit about radon, some basic stuff. If you want a course in the future, a National Radon Safety Board course, initial or recertification, let me know. We can certainly do that at Cornerstone. What is radon and how does it enter the home? Radon is a natural occurring radioactive gas that's colorless, odorless, and tasteless, okay? And it comes from decaying uranium. And it's been around a long, long time, but we really, if anybody out there knows, when did we start testing radon in the United States? What year? Just give me a quick year.
I have no idea.
1985. 1985 is when we started. And not getting in the story on that, there was a professor at a nuclear facility in Pennsylvania, and he was setting off the alarms, and everybody was like, what's going on here? And then they went and tested his house and found out he had high levels of radon. And that's kind of how this all started. So let's talk about how radon gets into the house. Radon enters your home. The house is under, if you've ever opened your basement window in the summertime and and there's no wind and you get a cool or you get a warm breeze that comes in, that's because the house is under negative pressure. The stack effect, like a chimney, as hot air rises in the house, it creates more negative pressure. So of course, when that air is rising through the house, it's going to draw that gas in. It's going to draw the radon gas in. Now, I hear all the time people go, oh, my house is brand new, it doesn't have radon. That's not true. New homes, old homes can have radon. And sometimes some of the highest levels that I've had in Connecticut have been 200, 180 had older homes, not necessarily new homes. And I've also had newer homes that's 60, 80. So it really doesn't matter if it's new or old. I mean, certainly depends on the construction, depends on a whole lot of other factors. Radon can be elevated in many different homes. It can come through. Where I see it as a radon mitigator is a lot of these waterproofing companies that come in and they leave the perimeter footing drains open. It can freely move in through there. If you're doing a home inspection and you see along the foundation wall, there's a little shrinkage crack where the slab meets the wall, okay, it can come easily through there. It can come through floor cracks and come through utility. The other problems that I see is when you have a finished basement and the builder has a cutout for the plumbing trap, it can enter through there. And most builders, when they put the tubs in, the showers in, they don't seal those up or foam them up. I just did a bathroom at my house in the basement. I made sure I sealed that all up. It can come through a lot of times when the sewer pipe, the builder will put a sleeve through the foundation, and he'll run his pipe through that. Radon can come in through there. Radon can even be in the building materials. I mean, there has been reported cases that there have been higher levels on these high rises because the stone and aggregate that they put in the concrete had high levels of radon. There are probably homes that had lower levels, and then when they bring in all the stone, or they do these nice fireplaces and all that, there could be some levels within the building materials. I haven't had a house where building material was an issue. It's usually below the house itself. It wasn't necessary in the building materials, but it's possible with some of these stone, cobblestone, and stone foundations. Radiation types. There's 3 types, and we can spend a whole type on alpha, beta, and gamma. Alpha, which is the largest particle, that can't penetrate your skin. Okay, it can't penetrate your skin. The only way it can get into your body is when you breathe, when you inhale. So I joke around with people, if you walk down the basement and held your breath, radon wouldn't affect you. So it's the largest of the 3. Gamma would be like your X-rays. If your X-ray gamma radiation, it can penetrate, takes X-rays. It has it has a lot of energy, and it can penetrate through your body, as well as beta, which is a little bit smaller than alpha. And that has less penetrating power. Gamma is obviously the biggest one, but for us, it's alpha. Alpha particles are the ones that affect us and that can cause damage to our lung tissue, can damage the DNA, and it can cause lung cancer. And people say, oh, I don't believe in it. Well, there are doctors, oncologists out there that can kind of tell what type of cancer it is. And there are times where I have been asked, because somebody had gotten really sick, to test their basement. Maybe some of you guys out there have been asked to test the basement to see if there were high levels of radon. Sometimes there were high levels and other times there weren't. Again, it can enter the home through a lot of different areas. It can go through the floor slab. I mean, if you look at concrete under a microscope, it looks like Swiss cheese, right? So the gas can get in even on a brand new house. But I always tell people, listen, did you ever go to a grocery store, or if you don't go to Hibachi, you ever go to Hibachi and you go to open the door of the Hibachi and they got all the fans on and you're pulling the door open and you feel all that air rushing in? Well, a poorly designed HVAC system can create more negative pressure in that house. And then when it takes all that air out of the house, it's got to come back in from somewhere. And of course, when it brings in air, the house is leaky. It's going to come through the windows. It's going to come through the foundation wall and the floor. It's going to bring radon in. So that's why you see a little higher levels in the wintertime, because of that stack effect, that chimney effect. As hot air rises, it creates more negative pressure. Our basement is under negative pressure. That's why we call it sub-slab depressurization. We not only are we sucking gas from below the floor slab, we're creating negative pressure below that floor slab, so it's more positive pressure above the slab. So not only are we drawing the gas out, we're creating pressure. We're trying to do that with a radon system. So if a house has a poorly designed HVAC system, sometimes the filters, when we're doing an inspection, the filters are open. If that filter is open and it's sucking air through the basement, that can create more negative pressure. Attic fans can create more negative pressure. Bathroom fans can create more. Kitchen fans, all that stuff. People say to me, I bought this house 3 years ago. The home inspector inspected it and never had a radon problem. Well, what was it? Oh, it was like 3. What is it now? 5 or 6. But they renovated their bathroom, their kitchen, they tightened up the house with insulation. So now the house is much tighter, and that can create elevated radon levels.
Hey, Scott, can I ask?
Sure. Did you have a question?
Good question. When I get to a house, I have a question. When you get to a house and the windows are open and the people are trying to air out the house, they feel, because they know a radon test is going to be coming on. My thought was always that sort of just makes it worse, because it's allowing the radon to come in and pass through the house rather than shutting the windows and not having that flow of air.
Good question, Jim.
Is it?
Well, it's a yes and no. Here's the thing. Depends on where the windows are open. if you open the basement windows, the solution to pollution is dilution, right? So if we open the windows, I mean, we've had those inspections where you see all these fans in the basement, right? And I question, why are all these fans? If you open the basement windows and you blowing air in, and it's probably going to dilute the radon. If you open the second floor windows, you're right. It could raise the radon, and we tell our clients, hey, if you open the windows, it could make it worse. But how is it making it worse? By if the air is going from the basement and up out through those windows, it's creating more negative pressure. So it could elevate the radon levels. It may not. And again, when we test as inspectors or radon mitigators, I mean, you can't close the house up on an elderly lady that doesn't have air conditioning. Like this time of year, I mean, you got to test, you got to do the best you can. But yes, you're correct. If the windows are open on the second floor, you could actually increase the radon levels by creating that stack effect, air going up and out. Basement windows, if you open them, you're probably not going to have an issue. It's going to dilute it. Just on the second floor or third floor of the home, you could elevate those radon levels.
Okay, thanks.
So the exposure to elevated radon level increases a person's risk of developing lung cancer. I mean, they say there's about 21,000 deaths every year. I mean, there could be other occupational exposures. If somebody's home and they don't work and the radon levels are very high, it's probably the radon levels. But if they work in construction and they're exposed to all kinds of other stuff, you just don't know. So let's go here. We talked about how it damages the lungs. It damages. So cracks in the floor. As a radon mitigator, any cracks I see, not the hairline cracks, and sometimes you see those control joints that the builder puts in. Sometimes they just cut that with the K12, and if you I'll stick a knife in there and it stops. It's just cutting along the top. Those I don't seal. If they go all the way through or they cracked open, I'll seal it. I'll seal all the way around the perimeter of the foundation with caulk. And sometimes when you get to that last foot or so, you'll hear the air kind of shh. And because at first, a lot of people are like, it doesn't do anything. Radon systems will work even if you don't seal it up, but it'll work better. The way I explain to the clients and the way I explain to everybody, it's like sucking water out of a glass of water with a cracked straw. We've all had that crack in the straw or broken when you slam it and you try to get the paper off and you put it in the water and you try to suck it out. You can get it out, but you got to suck harder. So sometimes we can adjust fans and do other stuff. So construction joints, cracks in walls, more so the floor than walls. But yes, radon can come through the wall. Gaps in suspended floors. Sometimes a floor that's cantilevered into the garage from the main part of the house, that can allow radon in the house. So when you have a problem house or a house that you can't get the radon down, you got to look for other sources. Patios. I mean, we can talk about how a patio can actually keep that radon from dissipating outside and can go into the house, especially if there's a cantilever. Water supply, we talked about that. So here's the one, the action level for us as inspectors, the EPA sets it at 4. And people always say, well, what is 4 better than 3? Is it better than 3.9? Based on my experience and Stan, who's also done radon, 4 is an achievable, less than 3.9 or lower is an achievable number. Would I like to see it lower than that? Absolutely. We want to see it as low as we can get it. But 4 is achievable. And, when you have a radon level of 60 and I get it down to 3.9, everybody's high-fiving me. They're like, oh, you're the best mitigator in the world. When you have a radon level of 4.2 and you get it down to 3.9, people are like, oh, geez, I thought it would go lower. So, sometimes the lower numbers are a little bit more challenging, and we'll get into that a little bit. There's still a risk at 3.9, at 2, at 1, there is always a risk. And people go, I want my radon 0. Impossible. We can reduce the levels, reduce your exposure, but there's always going to be a radon level in the house of something. 0.5 is great, 1 is good, 1.7 is good. And again, where do you spend most of your time? My house, I spend a lot of time in my basement. I have a radon system in my own home. Some people don't spend any time down in the basement. And there's a difference between when you're selling the house and when you're just somebody testing their house. Because you might have some people that go, I never go down there. I never use my basement ever. Well, then they may want to test on the first floor. We as inspectors, when we go out and test, the basement's finished or unfinished, or they're going to finish it, we're going to test it because that area could be occupied once they move in. They could renovate it. And it's always good to test it before you finish it off, because if you have to put a system in, it's a lot easier to box in the pipe and make it so you don't see it. Now, people go to me all the time. Well, the World Health Organization sets it at 2.7. And they say, well, we want it less than 2.7. I've had actually people say that. And I say, well, we go by the EPA and it's less than 4. But if you really think about it, the EPA says fix your home 4 or higher and consider fixing between 2 and 4. So, I mean, what's the difference between consider and fixing? Can we get the levels less than 2? I would say anybody that has asked me to get as low as I can, I tell them it is achievable, but we may have to do more work than our standard 1 suction point. We can put 3, 4, 5, 6 suction points if we have to, bigger fan. Most of the time, if they want it less than 2.7 or less than 2, I tell them up front, let's try it with 1 system. Let's get it below 4 and see what it does. And a lot of times it goes down very low and they're very happy, and we don't have to spend a lot more money. And I try to be fair with the people when I'm doing those mitigations. But yes, we can. I do get people that say, my kids are down there and I want it as low as you can. And the answer is yes, we can probably do it. It's definitely challenging. And there are things that we'll talk about shortly that can make it much harder as a mitigator to get those levels down below 2 if they want it. But as a mitigator, we're looking for 3.9 or lower. Some companies out there say we guarantee to reduce the levels. Well, if it's a 10 and they brought it down to 5, they reduce the levels, but it's not below the EPA level of 4 picocuries. This cost is in Connecticut. It's actually higher now. It's a little higher. I mean, obviously materials and everything have gone up, but this is not too bad. In some areas of the country, it might be less. But this isn't a bad start. It's relatively inexpensive compared to lead, asbestos. Some of the other mitigations out there were relatively a low cost. And most of the time when we test as a home inspector, most of the time the seller usually negotiates or gives them a credit. But not always nowadays. I know it's been tough. So the state of Connecticut recommends, and maybe other states as well, recommends to use a certified mitigation provider. Why certified? I mean, it's not super difficult, but when there is a problem, I mean, we went through a lot of training, Stan and myself. We went to Rutgers University and we thought we were going to have a good time and all this. And it actually was a very, very challenging course and we learned a lot. But where you really learn is when you're out in the field and you have those homes that are difficult to mitigate and you try different things, you try things that you were never taught. And sometimes it works and sometimes you scratch your head and you got to rethink on your approach on how you're going to fix this house. But they want us in Connecticut to be certified with the NEHA, National Radon Safety Board, National Environmental Health. I used to be NEHA, now I'm National Radon Safety Board, not NRPP anymore. And they want us to be a contractor as well and maintain those certificates in order to get listed on the website and everything. So most of the guys that take this course, they've gone through the training and do I see things that they're not their things that do I see stuff out there they're not doing right? Absolutely. And we're going to talk about it. And these guys are certified, so they should know better. Okay, let's talk about the several different types of radon mitigation. There's subslab depressurization. As the name is subslab, SSD, subslab depressurization, we're actually creating more negative pressure below the floor slab, so there's more positive pressure on top of the slab. So that rather the basement's under negative pressure, we're trying to switch that. We're trying to put more negative pressure under there. So that's the most common. When people say to me, well, I'd like to do an HRV, heat recovery ventilator, that's going back to Jim's question, is if we open the windows. Basically, an HRV is bring in fresh air. Problem with HRVs is it only reduces by half. So if the levels are 10, you may only get a 5 or a 6. If the levels are 20, you may only get a 10. And then you have to change the filter, and it could be cold air. The best method is sub-slab and sub-membrane. Membrane crawl space, when we do a house with a crawl space, and there's a full basement and there's a crawl space. My house, 2 crawl spaces and a basement. So I have 3 draw points, 1 in the basement, 1 under plastic, 1 under plastic. So I have 2 sub-membrane and 1 sub-slab to reduce the levels. So that's the best method of radon reduction.
Make sure it's under plastic because you had a dirt floor, correct?
Correct.
Yeah. So you wouldn't put the plastic down in a crawl space with concrete floor.
No,
just
you're
for
absolutely correct.
Now,
that's a good question, Stan. It's to cover, correct, because you can't suck through dirt. There are some companies out there, waterproofing companies, won't mention their name, that sometimes to waterproof it completely, they'll cover the concrete and they'll go up the walls. So sometimes in that case, it's still sub-membrane, but it's on top of the concrete, or I may actually drill through the concrete and seal the plastic up. Sometimes they just want it completely waterproof. They might have a little sump in the corner. But yes, most of the time it's covered with plastic. It's covered with a moisture barrier. Now, there are times it's a very small crawl space. Some of you guys that do inspection, it's under a bathroom or kitchen. It might only be 5 by 5 and it's all dirt. Sometimes I'll just cover that with plastic and not put a draw point in there, and then do the basement and see what happens. And most of the time it's fine as long as it's covered. That's the important thing. There's sump hole suction. So you can put, that is my last resort. I've done a few of them. It works. I mean, heck, you got drains that go all the way around. There's pros and cons to it. The pros to doing it in a sump pump is you have drains that go all the way around. So in a sense, you're sucking all the way around the perimeter of the basement. You get a good draw. The cons with it is one, if somebody once you seal that sump up and the sump fails and the contractor comes out to replace the sump pump, you think he's going to seal that sump pump back up again? Absolutely not. Or not, he's not going to do it the way I did it, and it's going to leak. So the system is not going to work as well. The other thing too is if the system fills up with water, you may hear some gurgling noise. The other thing is some of these sump systems are open all along the perimeter and behind the finished wall, so it could leak. It could leak, which brings up why are the pipes near the wall? Everybody says, why do you put the pipe near the wall? People come to me, why wouldn't you put it in the middle of the basement? It makes more sense. Well, in new construction, ideally everything's gravel, and for radon systems to work effectively, it's communication. If I can communicate below the floor slab from one side of the house to the other side of the house, and if I have one suction point and it's all gravel's ideal. I can draw that gas all the way to that system and right outside. The problem is we deal with a lot of older homes, and sometimes it could be, I know one time Stan and I it had process under it, and it was so tight. Process usually under a driveway. You can have clay, you can have rock and clay, volcano rock, all kinds of stuff. The tighter the soil, the harder it is to mitigate. And we'll talk about, the different types of fans that we use. There's basically a couple fans that we use all the time. We have a high suction fan, tight soil, and a medium air velocity for gravel and all that. And then you can go high suction and schools, big footprints. You can go high CFM. We're kind of in the middle with the two of those. And then you can go up and down. And sometimes bigger homes, 3,000, 4,000, 5,000 square foot, newer homes, we'll go with a bigger fan. In some cases, I just did a house in Connecticut here where I put 3 systems in because it was 15,000 square feet. And I put 3 different systems because it just was easier to do it that way than run pipe all over the place. So 3 passive systems, and we'll talk about passive. So sump, to me, if I can avoid the sump, if it's my last resort, if that's all I can do, there's a picture coming up where it'll show it in the closet. I was able to drill a hole in the floor and I went next to the sump, but I didn't go into the sump. Then you have block wall suction. I think I've done that twice, where you actually go into block walls, you have a suction point in the wall, and it actually draws the gas that may come. If you have a problem with a house, sometimes, you say, well, where is it coming from? So it could be coming through the open block. Sometimes the blocks are open, and it could be allowing that gas, and it's coming up. So we do a block wall suction. We talked about submembrane, active crawl space. I'm going to say that one, I think I might have done it once, but it's very rare. If anything, I close the crawl space. The problem with active crawl space is there's plumbing in there. And if you're trying to create more negative pressure in the crawl space and draw the gas out of the crawl space, you're also bringing air in there. It's making it colder. You're bringing moisture in there. It can cause rot. You can have termite damage. You can have moisture damage. So doing a active crawl space would be like sealing the crawl space off and putting a pipe through the entrance and trying to depressurize that. That to me is probably a last resort. If you can get into the crawl space and cover it and do submembrane, that's ideal. Some of these old farmhouses that we deal with, there's multiple crawl spaces, you can't get in it. That's where an HRV may come in. Room pressurization, no, I haven't done that, where you're pressurizing it, keeping the gas out. Heat recovery, maybe count on the hand 5 times. Very expensive. You got to have balanced air in out. You got to have air going in, air going out. So sometimes they can put those on the HVAC systems, but for mitigators, I would say subslab, submembrane are most common, and that's what I do most of the time. There is drain tile suction, where here's the problem with new construction in Connecticut. Or in the United States, as of 2016, all new construction is required to have a passive system. Now, I've been fortunate that I've worked with a bunch of builders that have let me do their system from the beginning to when I make it active. The problem is a lot of plumbers are doing it. And not to say, hey, listen, a plumber, those guys know how to run pipe. The problem with a plumber is they don't, as a mitigator, I insulate it. I think about where I'm running it, because people complain to me. And I think if you remember, Stan, we had that house when Stan and I worked together doing mitigation. There was a guy that was complaining that he kept hearing it in his daughter's room by the headboard. It was loud. It was loud. It was loud. So, we tried to go there and quiet down the fan, put a smaller fan in there. So when these builders are having the plumbers do it, they're not pitching the pipe right, because you got to have a pitch to it for condensation. They're running it maybe in an area where you can hear some of that white noise from the fan. Some people, it's subjective. People go, is the fan loud? And I say, not really, but some people say it's loud, and some people say, I don't hear anything. And it also depends on what's below the slab. More resistance, higher suction fan, it could be a lot louder. So,
hey, Scott.
Yeah.
We have a question. Sorry to interrupt.
Sure.
Any areas where we may see a system installed that should be an immediate red flag based off the location of the installation? I think this goes into a little bit what you're talking about with, like, I know that you're not supposed to have the fan inside the basement, right?
Good question. I know the question is, here's the other problem going back with a builder is when the builders put the system in and make it passive. It's required in all new construction. Passive meaning it's in a sense, it's a radon pipe that goes from the floor slab, below the floor slab. There could be perforated pipe. They could have a couple, 10, 20 feet lengths running across. If it's in gravel, it's going to work. And then it's run all the way through the building into the interior. They'll say that an interior inside the building is is a better run than an exterior wall. To me, it makes no, and they say, oh, if you put it inside, well, if you have a chimney, certainly a chimney that's surrounded by, it's surrounded by warm walls, you'll have a better draft and it'll draft better. I have a chimney that's on the outside and it doesn't draft well. Obviously, my chimney in the center drafts very well. Radon systems up the center. That's why a lot of these new homes, they're running them up the middle because they feel, oh, it'll be better for a passive system. It'll work better. Okay. So when you have these builders putting these systems in, and all of a sudden they say, oh, the radon's high, come in, and can you do what you have to do? So I go there and I go, well, where's the attic? And they go, what do you mean? I said, well, I have to get up in the attic to put the fan in the attic. And they say, well, there is no attic. So what they've done is they run the pipe up through maybe a vaulted ceiling, cathedral ceiling, up into a finished area of the attic you can't get to. So they're like, oh, you just put it in the basement. And I say, well, you're not supposed to put it in the basement. It's supposed to be in an unconditioned attic. You can put it out in the garage. You can put it on the exterior of a home. So going back to what you're saying, Jim, is you're saying when you see a system in a house, right? Mm-hmm. And we go there as inspectors or we go there to mitigate. Here's the problem I see is now the only spot I can do is in the basement. And everybody goes, well, why can't builders are like, well, why can't you put it in the basement? It doesn't need to go in the attic. Well, if you damage the pipe, if somebody hangs a picture, if somebody drills through the wall and they put a hole in that pipe, if the fan is in the basement, it's going to push the air out through that hole and you're going to have radon within your walls, okay? If there's a weak spot, the weak spot is where the rubber fern cones are on the fan. If somebody loosens it or over time it loosens or was never tightened up, now radon, instead of being drawn from the attic up, sucking up, you're blowing it up all over the place. So that's why they want it in an attic, unconditioned attic. Because if you put a hole in the pipe, you're not blowing radon within the wall cavity. You're just sucking everything up. That's why they want an unconditioned attic. Here's the problem today. We have all new construction in Connecticut. A lot of it in Connecticut, we're all seen as inspectors. Everything is spray foamed, right? So when you spray foam the attic, is it conditioned or unconditioned?
Well, if there's no heat source, it's unconditioned.
Technically, you're correct. No heat source, technically, you're right. But when you go up in an attic and it's 100 degrees out, it feels pretty comfortable, right?
It's conditioned, yeah.
It's technically part of the building envelope. So here's the problem. And I've had a big, long talk with the radon guru out there, and Bill, a Broadhead. He said that they're looking into, and this is in the future, making some sort of containment area for the fan that has an outside vent. So now if that fan were to leak or those fern cones were to dry out and it would blow into the attic with all that spray foam, technically it's in, even though it's not heat or AC, technically it's considered a conditioned area. It's part of the house now. Everything below that spray foam insulation that's between the rafters is now below that. Your radon fan is now kind of in a conditioned area. The other thing we do, right? We go do an inspection. We open up the knee wall doors in the attic. It's all finished on one side, and the other side, you got the air handler and the radon systems on the other side. If that fan would potentially leak, right? I mean, you may have a soffit. It may be spray foam insulation, so that gas could enter the attic. The reason they want it on the outside and they want it in the attic or the garage is if there was a damage to the pipe, it wouldn't blow the radon through the house. And that's really what it's all about. We tell everybody every 2 years, test your home. Obviously, if it's not working right, the radon levels are going to be high. Most people, after a mitigation is done, you give them a device to test, because we're not supposed to test what we mitigate, but we certainly can give them a device, because I want to know, did my system do the job? And I want to know immediately so we can go back and fix it, make repairs, or do whatever we have to do. The biggest enemy for radon is water. Radon system will not work if there's any water below the slab. I shouldn't say that. It probably will work a little bit, but it's not going to work well because you can't move air through water. So example, back in February, I did a radon system in Connecticut, and it went from a 13 to a 2. Everybody was happy, got the levels down. I get a call March, radon systems, the levels are back up again. And I said to the person, is it working? I said, take a picture. Because we all know there have been times I've gone out there and it's not working, and you got to turn the switch on, or the little YouTube is pulled out, or the breaker trips, and it's a simple fix you could do over the phone. You got to charge for your service call, but I try to work with people over the phone and help them out. So everything looked okay. I went out there, cut the pipe, pulled it out, and the water was up to the floor slab. And it had just rain, March, April. I'm trying to remember. We had quite a bit of rain. There was a homeowner sump pump. The old chimney flue dropped into the floor, and then they drop a sump pump in there. That was full of water. Clearly, I said to the homeowner, you have to address the water. You have to put a sump pump in. There are times I tell people, if there's any water issues, and people say, we've never had water issues. Never had water issues in the house. As soon as you drill a hole through the floor, it could be soaking wet. There could be a little water, but not high enough to flood the basement or to have significant seepage, but enough where when you put that pipe below the floor slab, it's not going to work. You're going to hear gurgling noises. And every once in a while, I'll get the phone call. I hear a gurgling noise. I tell them to shut the fan off because it's going to migrate to that area. You've created a bell-shaped hole there. Water's going to migrate to that part where, people go, well, will this cause a problem? No, if there's not a pre-existing problem and there's not hydrostatic water pressure, the radon system is not going to cause a water problem. Never going to cause a water problem. If there's problems, it's going to be popping up through cracks. We've all done those inspections. When I see the cracks with all the efflorescent, I see the rusted columns, I see staining everywhere. Like this house yesterday, there was a water problem. And I told him, we'll put the system in, but you need to address the water problem. Now, his gutter, the downspouts are dumping. There's things that we can do outside. We talk to people that can certainly help reduce the amount of seepage, window well, everything that we recommend as a home inspector. If you are a home inspector and you have open window wells, gutters that are downspouts that are dumping, full of leaves right by the foundation, that is all. If there's a radon system there, that's going to be a problem, especially if it's dumping right in the corner where the radon system is. It's going to eventually work its way down, and I'll get a phone call that I hear gurgling noises. So let's talk about a passive, real quick. Passive system. All new construction has to have a passive system. It can be made active. The other problem is electricians forget to run the electrical. Sometimes they forget. So I go up in the attic, I try to cut in the fan. Now I got to wire it. So that's another thing too. If you see new construction, is there an outlet there? You don't have to say anything. You can always say, hey, contact a certified, qualified, licensed mitigation just to make sure everything's running fine. That's fine. But what I'm going to give you tonight is hopefully going to help you out a little bit. And if you got to give me a call, I still get guys shoot me pictures and ask me questions all the time. So this hole in this picture over here, you see a little hole? We core about a 4-inch, 4.5-inch. Some guys will core 5-inch. I like a 4.5-inch hole, dry core. And then I have a little tool I get under there, and sometimes it's a screwdriver, and we take out a bell, like picture a bell upside down. It's not so deep, it's wide. And we want to be by the footings. Why do we want to be by the footings? Why not in the center? Why do we want to be by the footings? What can help us when we put the system near the footing? The reason we go ahead.
Like the pressure from how
well, over time, sometimes you have drain tiles in there, right? The other thing too is over time, sometimes the soil, it falls away from the footing, and there's a little void space in there. Void spaces are good. Any gaps or void spaces, sometimes there's a void space, so we dig along the footing on both sides, and hopefully you can draw all the way around the perimeter. All the way around the perimeter of the house. So it gives us a good draw when we're close to the footing. If it's really wet, Sometimes we'll go in the center of the center. I'll go towards the center with multiple draw points. If there's multiple sump pumps and it's wet and it's always going to be wet, sometimes we have to go with 3, 4, 5 draw points, and we have to go into the center. If there are drains, we do all this new construction, you go down in the basement, or you do a house that's been renovated with a permit, without a permit, and there's a waterproofing system in there, and there's 1 inch or there's a 1/4 inch gap where all the drains go around the perimeter. Well, if we put our suction point near those drains, it's going to leak. It's going to lose suction. You're not going to get a good draw, and you're going to have to relocate that to the center of the room. So when there is a problem, that's usually and the walls are up. Sometimes you have to take the wall down and seal it. Other times you can put a stronger fan and move it. So looking at this one, let's go to the next one here.
We have 20 minutes left, so we should get through these slides.
So if you look here, you can do an attic install. Here's the attic install. Okay. Here's a garage install, and here's an exterior install. Okay. This one on the right is a basement install. You're not supposed to do it in the basement. And it looks like it might even be in a sump pump. And I don't know, can you see my cursor on there? If you look here, this is the weakest point. And if somebody damaged that pipe, it's going to now blow through the whole house. So outside, attic, or garage. So here's the thing. And I see this all the time. And if you guys see this all the time, it might be something to point out. There should be a disconnect, whether you plug it in, whether there's a switch. I always like to do a switch. Whether there should be something within eye shot of the fan. If it's 6 feet away and you can still see it, or it's around the corner, they plug it into a G5. As long as one is there, it's good. And it makes it, if there's a problem with the fan, I can disconnect the power and I can change the fan without the homeowner being home. I still like to look at the whole system if it's not my system, but I can certainly work on it without them being there. So you want to make sure that there's a disconnect. So many companies out there that are certified, they don't follow the ASTM 21-13 radon mitigation standards. Those are our codes. The radon mitigation standards, and you have to have a disconnect. Okay. You can also, when you're there, if you guys are around outside, make sure the fan is on. Make sure that switch is up. It might be sideways, on, off, left or right, depends on how they put the cover. Make sure it's on. Put your ear up to it. Put your hand on it. See if it's running. See if it's running. If it's not running, you could say, hey, it's not running, and let the buyer know, or the seller. Sometimes we do pre-sale inspections, know that it's not working. Pipe. Schedule 40. That's all I use. There are some companies that use Schedule 20, thin wall pipe, the old drainage pipe. It's garbage. Now, it's cheaper. And technically, if you use the thin wall stuff, which you could, inside, you have to transition to Schedule 40 outside because of the sun, the cold, the exposure to all those elements. If you use the thin wall stuff, it's going to crack. It's going to crack. It's going to get deteriorated. And when I go to replace a fan, I tell people, listen, I'm going to be careful taking this fan off, but it could break and I might have to replace it with Schedule 40. Schedule 40 is the same as plumbing pipe. Same as plumbing pipe. And yes, I like to turn it so I don't see the labels. When you're putting plumbing in, the inspectors like to see the label and all that. I like to turn it around so it looks nice. We label every pipe. We have to label the system. Even if we do multiple draw points, I have little stickers, radon pipe, in the wall. Whether I do it with a marker or a sticker, what happens if a plumber opens the wall? Oh, look at this. There's a 3-inch pipe here. I try to label top and bottom in a wall if I'm doing an internal installation, because you can go through the house, or even the builders. When the builders put the pipes in, most of their plumbers that do the work, they do not label it. We label it in case somebody opens up the wall, somebody sees the pipe running through the basement. There are times that I'll tap, and my guy will be in the attic, and I'll be tapping to make sure that it's not a plumbing pipe that I'm cutting in the attic. That has happened before, but I make sure that it's a passive system. The manometer. I get people all the time to look at it and say, my radon level is good. It's 2. And I say, well, the manometer has nothing to do with radon levels. People think, oh, but radon's great. It's been running a 2. All that tells me that's just a device to let the homeowner know it's working. That's all it is. Now, for me as a mitigator, even as a home inspector, when I look at that device, the higher that fluid goes, the more resistance I'm seeing below the slab. So generally, new construction, a lot of gravel under the slab, it's going to look pretty close. It might just be 0.5, 0.4, it might be a little less than 1 inch of water column. When it's old house and it's real tight soil, that and also a fan can make it draw it up more. It could be up to 3, 4. So that tells me a little bit about, sometimes it's an old house and I put it on and it's only doing like a 1.5, and I'm like, okay, it's moving air. But for a client, you have to have a YouTube on there. There has to be a manometer. When builders do passive systems, they don't need any of this. Once you activate it, it has to be labeled. It should be labeled Radon anyways. There should be a sticker on there when it was made active. I always put on there that I did the fan, but I didn't do the initial installation. I just did the fan and let them know fan installation on such and such date. But the pipes should all be labeled. If you go there and you find out it's not working, if the system's not working, do we test? What would you do? Anybody out there? We're all home inspectors. Would you test if it's not working?
Well, I think you're going to test if the client wants the radon testing, but if the system's not working, the recommendation would be to get a radon mitigator out there to make it working, and then retest at that time once it's functional.
Exactly. To me,
yes, you should always test.
What was that?
Yes, you should always test. If it's not working, you definitely want to do a test and find out what the numbers are.
Yeah, I mean, sometimes, me, if it's not, I'd rather do it's a tough. Sometimes the clients, like Ron, sometimes the clients will say, listen, I'd like to know what it is before. And on a rare occasion, sometimes it's less than 4. You can test during a home inspection. Me personally, I'll always say, get it fixed. And it's not me, because I'm the home inspector. If I'm there as a radon mitigator and somebody knows that I'm going to fix it and then we're going to retest it. And then I'll test it afterwards. Now the question is, you got to make another trip back. Somebody's got it. Usually when I fix, when I change the fan, I don't always test it. If the client wants me to test it afterwards, I'll test it. Sometimes the fan will just get changed and it'll never get tested. So, if the client wants to test, I always, try to save them a little bit of money. I'm going to still go back and test it anyways, and maybe a little bit more, but you guys can do it. I always say, get it fixed and then retest. If they choose to say, listen, Ron, just test it. I want to know what it is before that gets fixed. That's fine too. I always just wait until it's done.
As an inspector, I always recommend that they go ahead and have it tested. And if it's not, now it's the seller's responsibility to have it repaired and retested.
Right.
It doesn't cost any money.
No, if it's working properly, you should always test. Absolutely. Always.
Yes.
If it's not working, if you happen to go up and say the YouTube looks like a U, it's not, you put your ear on it, it's not working, and maybe you're outside and you want to, you don't have to touch anything. You don't have to turn anything on. If you happen to notice the switch is off and you turn it on and it works, okay, I fixed it. Well, a lot of times it's a switch. A lot of times that little plastic tube on the YouTube pulled out, and you say, oh, I get agents call me all the time. It's not working. I say, take a picture, and the tube is just hanging there. It's not in the pipe. I say, put the tube in the pipe. They're like, oh, I just had one. You're a miracle worker. We fixed it. It's the switch is off. The tube is pulled out. I just had one. The tube was pulled out and they vacuumed it up. They don't know where it is. It's working. So if it's not working, what I was saying, Ron, if it's not working, you can, if your client wants you to test to see what it is, we know it's not working. The level's going to be high. If you want to wait till it's repaired and then go back and test, that's what I usually do. But certainly you can do it both ways. The other thing too is when you pull up, let me see here. Okay, here's the one. The pipe should be not a 90 below the soffit, not on this 2-story colonial that has no windows on the side, and the guy was lazy and he didn't have a big enough ladder to get all the way up top. The pipe should go above the highest eave. Okay? Now, It should go at least 12 inches. I always go 12 to 18 inches. You know, sometimes if I'm being aesthetic and I want it to look good, I'll keep it a little lower. If you're at the mercy of the house, colonial, you got a lower roof like my house and an upper roof. Mine goes on the lower roof because that's the only spot of the basement I could go out because the basement was finished. We're at the mercy of the house sometimes for the installation because that's the only spot we can go out. So we may go below, to a eave that's on the lower roof. As long as you are 2 feet above a window and 10 feet away from the window. Okay. So if you use a lower roof on a colonial, and I think there's a picture in here, let me see there. If the pipe is coming, if it looks like it's here, you're good. But here's another, I'm going to throw this at you. We'll just use this picture. See where that gable vent is?
Yeah.
Now, technically, attic is, the house is stack effect, up, out, you're okay. But, there are times where the pipe is very close to the gable vent. It's not the worst case scenario. It's not a window. That pipe, if that pipe was below a window, it has to be about 10 feet, 9 feet, 4 inches, 8 feet. I mean, as long as it's about 10 feet, if it's below the window, below that window, it has to be 10 feet. If it's above the window, it has to be 2 feet. So if it's a lower roof line, right, and you're above the roof, 12 inches minimal, 18 inches, it should be about 10 feet. If there's a window on the gable end, it should be about 10 feet away. And again, sometimes you got to do what you got to do. Just like sometimes I got to put radon systems in the fan in the basement because there's no other place to put it. And then, they'll sign a waiver saying if you ever sell the house and an inspector comes around, he may mention that this is not where it's supposed to be. It should be labeled. The pipe should be labeled, installation date. There should be a contact number on there. Sometimes they wear off. Sometimes there's stickers. There should be a warranty usually given to the seller. And with me, my warranty is transferable to everybody. It doesn't matter. If it's within that 5 years, that fan is warranted. If they could sell the house 5 times in 5 years, I'll still honor the warranty. That's the way I do it. Most guys are that way as well. The label, everything should be labeled. It should be properly labeled. There should be a manometer on there. The pipe should go above the roof line if you see it. If you think it's really close to the window, now there's a picture in here where the window goes right up to the soffit. That's where I would extend it a little bit higher. So it's not, nobody today opens the windows with the whole house fans. Maybe they do, but who opens the top part of their sash? Most of the time everybody's got their AC on, but it's supposed to go above that window. So not only do you have to label the fan, you have to label the piping, you got to label the circuit. If you can put a radon system, right, I'll wire it to the panel and give its own breaker. Other times I'll put it on an outlet. As long as the stuff isn't overloaded, you can tap into a junction box. What you can't do is use Romex and put a plug on it and plug it into the HVAC system. I see that all the time. So if you see some funky wiring, I don't need it, you guys. We're all inspectors. If you see something that's not wired right, it's no different with a radon system. If you don't see a disconnect outside, mention it, and then have somebody who's qualified to come out and take a look. There are some times where guys will see the fern coal and they'll say there's a bleb in the fern coal. The fern coal's got a bleb in it. So sometimes it's just the way the pipe was tweaked a little bit and it pushed on the fern coal. There's nothing wrong with the fern coal. So it's just maybe not a really good installation job. If your system is not working, check the switch, check the breaker, check to make sure the tube is in. The breaker should be labeled. And I'll tell you, I do it. I would say probably most of the guys out there right now, at least in my state, they don't label the breaker. They don't know. They just put it into a circuit. Mine are always labeled. Sometimes I got to trip the breaker and to find out what it's on if I put it in a junction box that's not overloaded. Make sure the tube is in. The way they did that tube is not really a good way to do the tube. But again, I tell the homeowners, if they don't think it's working, I'll tell them, put your ear on it. Do you hear air rushing through? And they go, yeah, I do. And usually it's working, and it has something to do with the manometer. This house, it was a house that I did that I had 1 to 5 draw points. The lady was an oncologist. She had a baby, and she says, Mama Bear does not want any radon, and I want it as low as you can. So I said, no problem. We put in 5 draw points. There were multiple. There was multiple areas. There was the boiler section. There was the basement area, and I just put the draw point in every area. Did I have to do it? She wanted as low as I can go, so I did multiple draw points and a real strong fan. So again, the pipe should have not, as long as the pipe is pitched to the first draw point. And the reason when we come in, we want a little bit of a pitch to the first draw point, and why when we come in, we always, if the draw point isn't near the wall and the footing, we want to pitch for condensation, moisture, so it goes back down to the floor. You know, you don't want to create a trap where condensation, you know, if the second and third draw point aren't perfectly pitched back to the hole, it's not the end of the world. It's usually the first one is where the condensation is going to occur. And I've done a lot of systems with copper downspouts. I've done a lot throughout the years. I found out when I use copper, it condenses a lot more. And I have to use a condensate bypass one I could make. So, you know what? Sometimes if they want copper, I do a PVC pipe and I paint it. Paint it copper, paint the fan copper. You can color match, sand, prime, paint. I can make it look like any house and make it blend in. This house here that I did, you could see, what did I choose to do? I did not go into the sump. I caulked the hell out of the sump. Everything on that sump, you see all my caulk, the gray caulk all around it, the pipe, the alarm, everything's caulked. This company's systems are sealed up pretty good, but I definitely didn't go into it, and it brought it down. This is you cannot do that. That pipe, I mean, you can go below the slab. A lot of times when we do a house slab on grade, a lot of people say, oh, the house is slab on grade. There's no radon. It doesn't go below the ground. That's absolutely, I've had some high level radon on slab on grade. Split levels. Basement's high. Did you test the slab? No. So we do mitigation of the basement and the slab that's on grade. So sometimes elderly senior housing, we have to go below the slab. You got to dig down and go underneath it. Split level. Sometimes I'll go through the block wall and under the slab near the bathroom in that area. So if you see the pipe, go ahead, Jim.
Scott, I'm going to interrupt you. We've got about 3 to 5 minutes left. We're going to finish up as quick as you can, but we're not going to do water tonight.
I'll bang it out quick if you guys got 5. This just shows you, this is a radon system. I'll get it. This is the radon system through the roof. It looks just like a regular plumbing vent. There's different fans out there, different companies. Let's go quickly over radon and water. Connecticut's 5,000. They recommend mitigation. Over 10, they want to go with aeration. What's the difference? The difference between, you have carbon and you have aeration system. Carbon, basically it's a big filter, and it does it by a process called absorption. So the radon molecules fill up the carbon in between the carbon, and it takes the radon out of the water. Passive. No mechanical, no pumps, no pressure switches. It just has to be changed. Should be changed every year. People sometimes wait. If you wait 7-8 years, it can be very radioactive. And then we shut it off and let it sit for a little bit. So it's granulated activated carbon, and that runs installation. It can run, I'd say, 18 to $2 grand in Connecticut, and to change it out every year, about $450 to change the tank. Depends on the size. And let me tell you something. This is the way we used to do it with carbon before aeration came in. You used to have 2 tanks, 2 big tanks, 10 by 54, 9 by 48s, tandem. You change one, then the other. So there's nothing wrong with that. But the problem is when you do radon and water testing in a vacant house, it could come back 5,000. Then people move in and they start using the water. You get deep in the well, and those levels you can retest, and the levels could be much higher. So just keep that. Even though we run it half hour and you do all your water testing, sometimes when you get in there and the people are living there, Aeration system. Basically, aeration system is a glass of water with a straw and you blow into it. As the water gets agitated, it releases the radon. It goes into a pipe and it goes outside into the atmosphere. And then there's a submersible pump like the well that actually pumps the water through the house. That's it. For you guys, I mean, you know, we can go into depth on this. You know, when you turn the water on in the basement, you should hear the pump kick on. And if you run enough water, you'll hear the blower kick on, and the blower is what agitates it.
Cool. And for every 10,000 in the water, it puts 1 in the air.
Correct.
And then what do you do if you have 15 comes back in the water and the air's 3?
Good question. I know we're at 8 o'clock, so
we'll finish up with that question.
We'll sum this one up, and I appreciate everybody. You know, I could be here for another hour, but here's the thing is it's 10 to 1. So for every 10,000 picocuries of water, it's equivalent to 1 of air. The problem is it's not when you drink the water. There's really no documented cases of drinking elevated radon level in water that can cause GI cancer. It's breathing it. So when you're in the shower and you're getting 10,000 picocuries coming out and you take a 10-minute shower, you could have 20, 30 picocuries in the air that you're breathing. If you shut the water off, you're fine. You flush the toilet, you're using the sink. That's where it becomes a problem. Because, you know, think about 10,000 to 1 picocurie really isn't that high. So in Connecticut, anything over 10, they recommend aeration. Aeration is probably the best method to remove radon in water. This cost is actually less. It's closer to probably now to a average house, probably 5,000 to 6,000. And then there's different systems that have everything. If you look at the ones that look like a washer, the bubblers, everything's all in there, the pump, everything. If you notice when you go there and you turn the water on in the basement, if the system's not working, it's either in bypass or there's a problem with the system. Most of the time, the system should be working. And again, you should always recommend to have a certified person come out and service the unit. The aeration system should be cleaned once a year. Bacteria, they have solenoid valves. They have the filters can be cleaned. Change the filters. There's a filter on this one. There's a filter on this aerator. The tanks can get manganese, iron, calcium. All kinds of stuff can get built up in there. And if that doesn't get cleaned at least once a year, all that stuff can clog up the unit and things can start to fail. So if it hasn't been serviced, that's another thing you may want to recommend, having it cleaned and serviced like we do on the HVAC equipment.
I think we're going to wrap up because it's a little after 8.
Sorry, I went 3 minutes over. Any questions, guys?
Well,
I don't have a question, but I have a comment, if I may.
Sure.
When we get a client that calls and has a radon mitigation system in the house, we give them 2 options. We suggest they should test to make sure the system works because in 21 years, we've only found 3 systems that didn't work. They had a mitigation system, everything looked fine, the manometer was right, fan was running, and they weren't quite getting the radon out. So we do suggest they might want to do that. Their other option would be anytime somebody has a radon mitigation system, we recommend they get their own radon monitor in the house because we found a few systems that didn't work. And I've had 2 women totally in panic when I found a system that wasn't functioning. They're like, when did it quit? My kids are living in the basement. My kids are playing in the basement. So a lot of our clients will decline the radon test and buy their own monitor because they know the majority of the time. And if there is a repair, it's going to be minor. It's not going to be $1,500 to put a system in. They got to fix a fan. They may have to put a second point in. But that's kind of how we approach a house that has a radon system. Just thoughts.
No,
thank you so much, Ron.
Listen, Ron, those are great points. Every radon system that is installed should be tested, even after it's installed. Because I'll be honest with you, there are times it doesn't come down. People will never test, and then they go to sell the house and it's tested. And even though the system was put in, there are times where the person will sell it a year or 2 later, and the levels come back high. They probably never came down. So we certainly tell people to test all the time, and we always recommend every couple of years to test, whether it's done with we have all these new home systems, but also have somebody certified like yourself to go out and do a test too, just to make sure, even before you put it on the market. But absolutely, testing is imperative. And
quick question, if I may. As a radon mitigator, aren't you required to test after you install the system?
Great question. Well, first of all, the system has to run a minimum of 24 hours. Minimum of 24 hours. I always say a couple days. You'll hear some people say, oh, 6 days. Minimum of 24 hours, it'll start coming down. I usually say a couple days. So for me, I would have to go back, set it up. So I provide a test kit. And we all provide a test kit. And if they want to hire, like they'll say, I want Ron, he's my inspector. You certainly, I have my test kit that goes to a third-party lab, and you as the home inspector can go back. And I've had that, home inspector will go back and test, and everything is good. Both levels are below 4 and everybody's happy. But you're absolutely correct that testing is important. We also can put alarms on the systems too. I have alarms. I don't put them on often. I'll offer it that if the system fails, that their alarm will go off. It doesn't work. And at least it'll alert the homeowner that it's not working. It could go off if the power goes out, but certainly if the fan fails, because you're right. There are times when people are like, I don't know, I sold the house and the inspector, Stan said it wasn't working. So
Ron, just to clarify, we have to provide a method of testing the system, but we personally don't have to. And as Scott said earlier in the presentation, a lot of people think that's a conflict of interest for the company to test their own equipment.
Oh,
a lot of people aren't up with that. I mean, we do if everybody is on board,
right?
But some people don't want us testing it.
If there's a problem, and we'll do diagnostic testing, And the other thing too is somebody will hire me, and not as a home inspector, they hire me as a mitigator and say, hey, can you test my house? I tested the radon's high. Am I going to say, hey, call Ron? He's, I'm going to do the mitigation too, So, you're supposed to have somebody else test it. And then sometimes the agents don't want to do it. The homeowner doesn't want to do it. But certainly I warranty my systems. So if the homeowner gets in and 6 months later, just tell your client, listen, get in there and then do your own test. And if there's a problem, call them, call whoever. I mean, they're under warranty, and if they feel more comfortable, and people do that all the time. But guys, I appreciate it. As you know, I'm an in-person guy, so I'm getting used to this. But at least I was able to move my hand sitting down. So thanks to our Massachusetts inspectors, Glenn, and I believe Gary. I think they're both Mass, right?
Glenn's Connecticut.
Glenn's Connecticut. Oh, sorry, Glenn. I apologize. I can't see with my glasses on. And Gary from Mass, thanks for coming, guys. If you have any questions, please reach out to any of us. We're here for you. And Cornerstone is going to get bigger and bigger.
Thank you, Scott. Thank you so much. And
thank you, Scott. Very nice presentation. Greatly appreciate it.
Thanks,
everybody.
Ron.
Have a good night, and check our schedule of events for upcoming events and webinars. Thank you.
See you later.